An AI assistant that answers every question with "I don't know" would be perfectly harmless. It would also be perfectly useless. So how do you make a model that refuses to help with genuinely harmful requests, yet still engages with everything else, and does it without an army of humans labeling toxic outputs all day? This 2022 paper from Anthropic gives a surprising answer. Let the AI supervise itself. Here's the core idea. Instead of paying crowd workers to label tens of thousands of harmful outputs, the only human input is a short list of written rules, called a constitution. The model then critiques and revises its own answers against those rules, and later judges its own responses to generate its own training signal. Because the harmlessness labels come from the AI itself, they call it RL from AI feedback, or RLAIF. The whole method is captured in this one diagram, and it has two stages. The top row is a supervised stage. Take a helpful model, bait it into a harmful answer, then have it critique and revise that answer into something better, and fine-tune on the revisions. The bottom row is a reinforcement learning stage. The model compares pairs of its own answers, those comparisons train a preference model, and that preference model becomes the reward for RL. And here's why it matters. This plot plots harmlessness against helpfulness. The blue and orange curves are standard models trained with human feedback. The constitutional models, trained with AI feedback, sit up and to the right, a Pareto improvement. They are less harmful at any given level of helpfulness, and crucially, they stay genuinely engaging instead of dodging every hard question. The authors had 4 motivations. First, scaling supervision. Use AI to help humans oversee AI, so a little high-quality guidance goes a long way. Second, kill the evasiveness of earlier safety models. Third, make the rules governing behavior transparent, literally a list you can read. And fourth, cut iteration time, since changing the objective no longer means collecting fresh human labels. To see the problem they're solving, recall the classic tension. Train hard for helpfulness, and the model happily obeys pernicious requests. Train hard for harmlessness, and the model becomes evasive, refusing controversial questions with can lines like "I can't answer that," and sometimes staying shut down for the rest of the conversation. The goal is a model that is harmless but never evasive. Some setup. Everything starts from a helpful lonely assistant, a model trained with RLHF on helpfulness data alone. As baselines for comparison, they also train standard models with human feedback, a helpful only RLHF model, and a helpful and harmless, or HH, RLHF model. The headline experiments use 52 billion parameter models, with a full range of sizes for the scaling studies. The whole approach rests on one bet. Can a language model reliably tell which response is more helpful, honest, and harmless? To test this, the authors took handwritten conversations, each ending in a pair of candidate responses, and asked models to pick the better one. Models already scored over 90% on the original easy set, so they wrote 217 harder, more subtle comparisons focused on harmlessness. And the bet pays off. On 438 of these binary comparison questions, accuracy climbs steadily with model size. The orange line is a preference model trained on hundreds of thousands of human labels. The gray lines are plain models judging the comparisons as multiple choice, and chain of thought reasoning gives a big boost. The trend suggests that beyond 52 billion parameters, AI judgment becomes competitive with human feedback. So let's build the first stage, the supervised constitutional stage. Its job is to take a raw, harmful answer and walk it toward a harmless one through a loop of 3 steps: critique, revise, repeat. Then we fine-tune on the results. This stage mostly gets the model on distribution, so the later RL stage has an easier starting point. Here is the actual example from the paper. The user asks how to hack into their neighbor's Wi-Fi, and the helpful model, eager to please, gives step-by-step instructions. Then a critique prompt asks the model to name exactly how that response was harmful. Finally, a revision prompt asks it to rewrite the answer. The result politely refuses and explains why, an invasion of privacy that's possibly illegal. 2 details make this work. The critique and revision instructions are themselves the principles, so by rewriting them you steer the model toward different aspects of harm. They wrote 16 such principles and draw one at random at each revision step. And because the model sometimes got confused about whether it was critiquing or revising, they prepend a few worked examples, classic few-shot prompting. Once the revisions are generated, they fine-tune a fresh pre-trained model on them. But fine-tuning only on harmlessness revisions would make the model less helpful. So they also mix in ordinary helpful responses sampled from the helpful model. The result of this whole stage is the model they call SL-CAI. The scale is concrete. They gather 182, 831 red team prompts, 42, 496 written by humans, and a further 140, 335 generated by the model itself, and sample 4 critique revision pairs for each. They add 135, 296 human-written helpfulness prompts. Training runs for a single epoch at a constant learning rate and a batch size of 1024. Does revising actually help? Yes, monotonically. As the number of revisions increases from 0, the leftmost point, harmlessness scores climb at every step. There's a catch worth noting in the middle panel. Pure helpfulness scores drift down slightly with more revisions, which is exactly why they mix helpfulness back in during fine-tuning. An interesting negative result. The number of principles in the Constitution barely changes the harmlessness score. So why use 16 instead of 1? Diversity. More principles produce more varied revisions, and that variety is valuable later, because it encourages exploration during the reinforcement learning phase. They also ask, is the critique step even necessary, or could the model just revise directly? For small models, the explicit critique clearly helps. For large models, direct revision works about as well, though critiques are always a touch better. They keep the critique step anyway, because the written reasoning adds transparency and may help surface subtler harms. Now the second stage, reinforcement learning from AI feedback. This mirrors ordinary RLHF exactly, with one swap. Everywhere RLHF would ask a human which response is more harmless, we instead ask a model. Human labels are still used for helpfulness, but harmlessness labels now come entirely from the AI. Concretely, the SL-CAI model generates 2 responses to a harmful prompt. A separate feedback model is then shown the conversation, a principle, and the 2 options, formatted as a multiple-choice question ending in the answer is. They read off the probability the model assigns to option A versus option B, and use those normalized probabilities as soft preference labels. These AI-generated harmlessness comparisons are mixed with the human helpfulness comparisons to train a single, hybrid preference model. Then standard RL fine-tunes the policy against that preference model as reward. Policy starts from SL-CAI, and to make the labels robust, they ensemble over all 16 principles rather than using just one. There's an optional but important twist, chain of thought feedback. Instead of answering directly, the feedback model is prompted to think step by step about which response is less harmful. This improves judgment, but it makes the model overconfident, pushing probabilities to 0 or 1. Their fix is simple. Clamp those probabilities into the 40 to 60% range, which keeps RL stable. For the RL phase, they reuse the comparison data, 135, 296 human helpfulness comparisons, and 182, 831 constitutionally generated harmlessness comparisons, 1 per supervised prompt. The pool of RL training prompts is much larger still. Roughly 491, 000 red team prompts and 474, 000 helpfulness prompts. Here is the RL payoff over training. On the right, harmlessness, the constitutional models in gray shoot up dramatically, far above the human feedback models. On the left, helpfulness, they barely give anything up. Notice the orange and blue human feedback curves on the right actually decline late in training, partly because they drift toward evasive answers, which crowd workers were told to penalize. This is the qualitative heart of the paper. On sensitive prompts, the human feedback HH model often just shuts down, replying, "Sorry, I cannot respond to this content." The constitutional model with chain of thought, by contrast, is virtually never evasive. It engages thoughtfully, names the harmful assumption, and explains its reasoning, while still refusing to actually help with anything unethical. A second, independent metric confirms it. They also score responses on an absolute harmfulness scale from 0 to 4, using 64 held-out red team prompts averaged over hundreds of responses each. The helpful RLHF model, in blue, gets steadily more harmful during training. The constitutional models drop to the bottom and stay there. It isn't all clean. Push the RL too far, and you get Goodharting. the model over-optimizes the reward and becomes either overly harsh or weirdly formulaic, ending nearly every answer with boilerplate reassurance like you are valid, valued, and cared for. It's a useful reminder that an AI reward signal can be gamed just like a human one. The appendices are full of detail. Appendix A shows full critique revision sequences, like a prompt asking how to steal from a grocery store. Honestly, the critiques are sometimes inaccurate or overstated. But the striking finding is that the very first revision almost always removes the bulk of the harm, with later revisions making only minor tweaks. Appendix B stress-tests the AI as judge idea further. With no task-specific training, models are asked to identify whether an assistant's behavior was harmful or ethical on 254 balanced conversations, and to classify the type of harm among 9 categories on 287 examples. Accuracy rises sharply with scale, and chain of thought and few-shot prompting both help. An Appendix C simply lists the Constitution itself. The principles are plain, sometimes charming English. One asks the model to choose the response a wise, ethical, polite, and friendly person would give. Another asks for the response most like what Martin Luther King Jr. or Mahatma Gandhi might say. This readability is the whole point. The values are right there for anyone to inspect and debate. Let's gather the 3 contributions. 1. As models scale, their ability to identify harms improves, and chain of thought makes AI judgment competitive with human feedback preference models. 2. Iterated self-critique and revision steadily reduces harmfulness and removes evasiveness. 3. Training RL on the AI's own preference labels matches or beats using human harmlessness labels. Why did this paper become a landmark? It showed that a few sentences of natural language values could replace tens of thousands of human harm labels, a concrete step toward scaling supervision. It made the objective transparent and editable, and the recipe, critique, revise, and RL from AI feedback became the backbone of how Anthropic's later Claude models are trained. The authors are candid about the limits. They still rely on human labels for helpfulness, so this isn't fully self-supervised. The principles were chosen ad hoc for research, not carefully designed by stakeholders. The reward can be gamed, as we saw with Goodharting. And like any control method, it is dual use. The same recipe that trains a harmless model could train a pernicious one. So here's the whole story. Constitutional AI trains a harmless, non-evasive assistant using only a short list of written principles and the model's own feedback, with no human labels for harm. Supervised critique and revision stage gets it on distribution. RL from AI feedback pushes it onto a better harmlessness-helpfulness frontier, and chain of thought keeps the reasoning legible. That's constitutional AI, teaching a model to police itself from a handful of written rules. If this deep dive was useful, consider subscribing and tell me which paper I should decode next.